Hello everyone and welcome to the second part of our series on cross-validation. In this presentation, we'll dive into the techniques and practical implementation of cross-validation. My name is Behzad Sabeti and I'm a member of Pattern Recognition Lab at Ferdous University of Mashhad. So let's get started. Before we dive into the details, let's start with a review of the most common cross-validation techniques. And the four main methods we'll discuss, which we had discussed before, are number one, k-fold cross-validation, which splits data into k subsets. And number two, leave one out cross-validation, or LOOCV, which where each data point is used once as the validation set. Number three is a stratified k-fold cross-validation, which preserves the class distribution in imbalanced datasets. And number four is time series cross-validation, which is designed for temporal data. Each method has its strengths and weaknesses, and we'll explore them in detail. Let's start with k-fold cross-validation, the most widely used method. Here's how it works. The dataset is split into k subsets, or folds, and the model is trained on k-1 folds and validated on the remaining fold. This process is repeated k times, with each fold used once as the validation set. The advantages of k-fold cross-validation include a reduced variance in performance metrics and suitability for most datasets. However, it can be computationally expensive for large datasets or high k values. Here's a visualization of how k-fold cross-validation works, as you can see. Next, let's look at leave one out cross-validation, or LOOCV. This method is a special case of k-fold cross-validation, where k equals to the number of samples. Here's how it works. Each data point is used once as the validation set, and the rest are used for training. This process is repeated n times, where n is the number of samples. The advantage of LOOCV is that it uses almost all the data for training, resulting in low bias. However, it's computationally expensive for large datasets and can have high variance in performance metrics. Here's a visualization representation of LOOCV. Now let's discuss a stratified k-fold cross-validation. This method is particularly useful for imbalanced datasets, where one class significantly outnumbers the others. Here's how it works. The data is split into k-folds, but the class distribution is preserved in each fold. This ensures that each fold is representative of the overall dataset. The advantages of a stratified k-fold is that it reduces bias in performance metrics for imbalanced datasets. However, it's limited to classification problems. And here's a visualization of the stratified k-fold, and as you can see, we have imbalanced datasets, and the imbalanced datasets are seen in the medical cases, so common. And now we have a practical implementation. Now we've covered the theory. Let's move on to practical implementation. Here's an example of how to implement k-fold cross-validation in Python using Scikit-Learn. We'll use the iris dataset and the logistic regression model. First, we load the dataset and split it into features and target variables. As you can see here, we import the necessary libraries, and here we load the data, and here we just initialize our x and y coordinates or data. Then we initialize the model and set the k-fold cross-validation with k equals to 5. As you can see, here's our model, and our maximum iteration for our logistic regression is 200, and the k is 5 for our cross-validation. And yes, that's it. And finally, we perform cross-validation and display the accuracy scores for each fold, as well as the mean accuracy. So, and here's the expected output which you will get, and as you can see, we have different scores for each fold, and we have a mean accuracy across all the folds. So to summarize, we'll explore the techniques and implementation of cross-validation. We discuss k-fold cross-validation, LOCV, and stratified k-fold, along with their advantages and disadvantages. We also saw a practical example of how to implement k-fold cross-validation in Python. In the next part of this series, we'll explore the applications and best practices of cross-validation, including how to choose the right method for your dataset and how to avoid common pitfalls. Thank you for listening, and I look forward to your questions.